Hello everyone, so this is the second part of the analysis of variance. So over here, what I would like to show you is that how we can perform test for equality of several variances. So we have multiple groups, that means the multiple population we have. So I would like to see whether they are actually homogeneous. That means there is no variation. The variation we have in between those groups are actually similar. So that means the variances we would get, whether they are similar, there is in one group what's the variation we have is similar to what's the variation we have in the other groups. So there is a popular test, what we call is the Bartlett test. So in the Bartlett test, we use the chi-square test. So I will show you how you can perform the chi-square test in the Bartlett test, so that we can find whether the variances are equal or not. So in the example, what I showed you, I will use the same example. That means the data set we had for the 4 treatments. So what we used, I would like to show you using the same example. So over here you can see that I copied the data set 4 treatments, and similarly what we used before, I calculated the variance, I calculated their sum of squares, exactly what we actually found previously. So in the Bartlett test, the hypothesis, already we want to find whether the treatment variances are equal, or the alternative is that treatment variances are not equal. That means at least one treatment variance is different. Okay, so we have to do a little bit of calculation. To do that, our main chi-square test, since we are using the chi-square test, so you can see that this is the chi-square test statistics we have to do. So how many groups we have? The degrees of freedom will be -1. That means we have 4 groups. The degrees of freedom will be 4 minus 1. So you can see that in the chi-square test. So we have to use that degrees of freedom. That means 4 groups, 4 minus 1, 3 degrees of freedom. And then based on what's the level of significance you are going to use, you can find the critical value. For the chi-square test statistics, that's the one we have to use. So we say that in the chi-square test statistics, we have to use Q by H. But what is that Q? What is that H? So in Q, you can see that we have to find what's the difference between the number of observation minus the treatments, how many treatments we have. So you can see that total number of observation, that means how many observations we have, 20 of them, and the total number of group is 4, that means 4 minus 1, and then log of SP square. So the SP square I will talk about later, so you have to use the logarithm of them, and then minus of each of those sample size minus 1, and then multiply by log of variance square. So that means you have to find them before. That's why I try to calculate each of them before. So you can see that the variance for each of the group, I calculated them before. The log, you have to use the natural logarithm. You can use your calculator or you can use Excel, but in the exam, be careful, you cannot use Excel because you only need to use the calculator. But for the assignment, feel free to use the Excel. And then the SP square over here, we have to calculate that before. The SP square is each sample size minus 1 multiplied by the variance we have. That means let's say this one. The variance we have in treatment group A is 10.8. That means that's the one we have to use, multiply by 5 minus 1 is 4. And then you have to go to the next one. So that's what I did. You can see that I took the square, I took the sample size minus 1 and then 4, and each of them are multiplied by their variance and divided by n minus k. That means the 20 minus 4. I found the SP square, and then I plug it in here, and then you can see that I found the Q value. So Q value, I use the variances, I use the SP square, and then the number of measurements and then treatments. I also use the logarithm. You can see I use the natural logarithm. And then I found H. H value would be 1 plus 1 over 3 minus K. That means how many treatments you have. 3 is constant, you have to use that. It doesn't matter how many, what you use, what's the example you have. You could have different example, but we always have to use 3. And then you have to sum them by 1 over sample size minus 1. That means each of those cases, how many sample sizes you have. So you have to sum that minus the constant part, 1 minus n minus k. So you can see that I use the each of cases I have 5 treatments. That means 5 minus 1, 1 over 4, 4 of them I have, and then I use the other ones. So that's how I found H value. And then the chi-square calculation is simple. If you get the Q and H values, I found those Q and H, and I added that in here, so you can see Q by H. I found the chi-square calculated value. And then the critical value using the 3 degrees of freedom, and then level of significance is 0.05. So I found that the critical value is 7.81. So you can go to the chi-square table and find that, the singular value you might find. And then the chi-square, you can see that the critical value is larger, and then the chi-square calculated is smaller. That means there is not enough evidence to reject the null hypothesis. So you cannot say that they are different. You can say that we cannot say the treatment variances are not equal, sorry. So that means we are going for with the null hypothesis, but we have. So if in some cases you will see that we have to perform this test first before we perform any analysis of variance, because we need to have variances are same. So you can perform this test first so that you can say that yes, variances are same. Then you can go for finding the ANOVA table so that you can find the differences between means. Okay, so that's what you will see that we are talking about in here, and then not much detail is provided here. That's why I showed you in the Excel how you can perform the equality of several variances. Then I would like to show you how you can perform multiple range test. So let's say we found in our ANOVA that the means, all means are not equal. That means one pair is different. So let's say while we were performing this one-way test that I showed you in the previous video, the means were same, means maybe at least one of them is not the equal. That means maybe A or B or B or C. So if we find that the null hypothesis is rejected, then which pair is actually different? If we want to find that, then we can perform some multiple comparison test. So in the multiple comparison test, the test for means, which pair is different, there are several tests. You will see that one of them is Bonferroni's test. In Bonferroni's multiple comparison test, we can see that which pair is different. Or sometimes you will see that people try to find the differences for all combination of treatments or all pair. They can do the t-test as well. And then Bonferroni is easier rather doing many t-test. So in Bonferroni's test, the main item is we have to find the value CD. If you find this CD value, then you can compare them with the differences you have in each of those pairs. Okay, so to do that, I would like to use this example, the example we used before. That's the example we have. We have 4 treatment groups, and then we have the treatment means. I will use the same. So you can see that side by side I also kept the ANOVA table. This is the ANOVA table for one-way analysis of variance. And then at first I need to find the level of significance, because level of significance, previously we have the 0.05. Since we are comparing many different pairs, that means we need to divide our level of significance as well, because level of significance, what you have 0.05, you have to divide by 2 multiplied by how many comparisons you have. So that means at first we need to know what m is. In terms of m is the number of combinations. That means since we have a, b, c, d, all these treatments, how many pairs we can have. So we can have 4c2, so you know nc2, so that means we can have 6 pairs. So pair could be a, b, b, c, c, d. So how many of them you can just easily find using the n choose 2, and then you can find that. So that's what I find. There could be 6 different pairs. For each of them, since we have the means, but I would like to rank them, which one is smaller, and then the next one, then smallest to largest. I try to find that. After that, then you can see that we have the level of significance. Since we have 6 comparisons, then we divide the level of significance 0.05 by 2 multiplied by m, that means 12, and then that's the level of significance we have to use. For the Bonferroni's test, you will see that in the book we have a different critical table. We have to use the Bonferroni's critical table for this analysis. If we have unequal sample size means, I talked about it before, the sample sizes we have varies. That means in treatment group A, B, C, D, if we have different sample sizes, then we have to use the unequal sample size, or if we have equal sample size, then we can use that. The CD value is the measurement what we will be using. So in the CD value, you only need to use the t value and then square root of which 2 pair you are going to use, the sample sizes in there, and then mean squared error. That means in the ANOVA table, the MSW within treatments MS mean squared, what you found, you have to use that. Okay. If it is equal sample size, then you just need to divide by n. So I have equal sample size, that's why I use this formula, and then you can see that at first I try to find what would be the t value. So t value you can see using the Bonferroni test. For the Bonferroni test, we have the critical value for Bonferroni test in a new table. It's not the t table, so you have to use that table. In that table, if you can see what's the number of comparisons. The number of comparisons we have 6 pairs, so you can see for C2 6 pairs, and level of significance was 0.05, and then we use the degrees of freedom is 16. So in that case, so you can say I'm not using 0.042 because it's already mentioned that we have 6 comparisons. So you will see that the t value would be 3.01. So I use this t value, and then I use the 2 mean squared error divided by n. So that means the 7.1 multiplied by 2 divided by the sample size is 5. So I use that, and then you can see take it over here. Okay, so that's the value I used, and then I found the CD value is 5.07. Now it's the time to find the comparison. So you can see that to compare them, what I did is that I have to take the absolute mean difference. That means there shouldn't be any negative value. So I calculated for each of those means, if I take the difference for each of those pairs, then what would be the absolute value of them. So I just calculate the absolute value difference between the means, and then I try to see if the difference we have is greater than the CD value or not. If we find in any difference, if any of them are greater than the CD value, that means they are actually different. If they're less, they're not different, they're similar. So you can see that I compared them with the CD value, and I found that only CB, this pair, and then AB, this pair, that means A and B, and C and D, these two pairs, we found that their value is actually more than the CD value. That's why they are significantly different. That's how you can perform the Bonferroni multiple comparison test. So you will see that that's the same thing we did, and then sometimes people use the try to see if they are significantly different or not. They use these lines, so you can see that B and D are same, D and A are same, but you can see which values are not same. C and B, they're not the same. That's why there is no line between those two values, two groups. Okay, so what we learned is that how we can perform the test for equality of several variances, and then how we can perform which pair of means are different. Okay, that's it for now. Thank you.